All right, today we're going to be going over the Module 6 test review. Number 1 says, Sean solved this system of equations by graphing. So we're going to use our graph, and we're going to graph the system. So I'm going to rewrite it on the bottom so we can graph it. Okay, so I'm going to start with the first one. I'm going to use this one in black. So first, I know my y-intercept is always where I want to start. So my y-intercept in this case is -1, so I'm going to graph -1. And then we have our slope. Remember, your slope is the number attached to the x. And in this case, my slope is 4/5. So I know my directions are up 4 and to the right 5 because it's positive and positive. So I'm going to go up 1, 2, 3, 4 over 1, 2, 3, 4, 5. Can also go the opposite direction, doing the complete opposite, down 4, 1, 2, 3, 4, to the left 4, 1, 2, 3, 4, 5. Connect our dots, and we have our line. And now we can do the next one. We're going to do this one in blue. So we've got a y-intercept of +1 and a slope of 2. Now remember, if you don't have a rise over run, you can always turn any whole number into a fraction by putting it over 1. So now I know I'm going up 2 over 1, up 2 over 1, up 2 over 1, or the complete opposite, down to left 1. Down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. Connect our dots. And we have our system. Now what we're looking for is that point of intersection. So let's try and figure out where that point is. So we know it's about -1. It's not quite at -2, so we're going to say -1.5. And then we've got down 1, 2, a little bit past -2, so we'll say -2.5. And we'll see which answer choice gets us closest to that. All right, so letter A says the y-coordinate of the solution is between 0 and 3. Well, we know it's definitely negative, so it can't be A. The x-coordinate of the solution is between 0 and -1. It's definitely past -1, so it can't be B. The system has no solution since the lines are parallel. Definitely not parallel. They have a point of intersection. They don't have the same slope, so it can't be C. The x-coordinate of the solution is between -1 and 0 and -2, so -1, -2, definitely. And the y-coordinate of the solution is between 0 and -3, also true. The system has infinitely many solutions since the lines coincide, also not true. They are two different lines. So we've got our first one. Number 2, to solve this system of equation, what is the y value of the solution? So we need to solve for y. That means we can cancel our x's. So let's use elimination to solve for y. So you could start with the x's and then plug in to find y. In this case, because it's only asking for a y value, I think it makes more sense to just cancel out the x's, find y right off the bat. So step 1, make sure our variables are aligned. Well, I've got x's with x's, y's with y's. So step 1, good. Step 2, decide what letter to cancel. We're going to be canceling our x's. In order to cancel, we need same number, different sign. Well, I already have them different signs, so that part should be easy. I get to multiply by positives, and I need to decide what number to get them both to. So let's start with labeling our tables. First, we have 4, our 4 table, 4, 8, 12, and in front of every letter is the number 1. So we've got 1, 2, 3, 4. Well, I see that they have a 4 in common, so I can get them both to be 4. My top is already +4, I'm just missing a -4. Bottom is already negative, so I can just multiply it by a 4. And we can start rewriting, move on to step 3. So I'm going to rewrite it. Top stays the same. Bottom, everything is multiplied by 4. So we've got -4x plus 12y equals -32. And now we add it like it's one big addition problem. 4 minus 4 is 0. -1y plus 12y is 11y. 11 minus 32 is 21, -21. And using opposite operation, we solve for y. Divide both sides by 11. I get y equals, I can't simplify this. I can, but I'm going to get a decimal. So I'm just going to leave it as negative 21 over 11. And if I notice, that is letter B. All right, it says Teresa works at a hot dog stand. She sells 4 hot dogs and 2 pretzels for $18. She sells 3 hot dogs and 3 pretzels for $21. Complete the following sentence. So is, well, I know that I've got 2 variables happening right now. I've got my hot dogs, don't know how much they cost, and my pretzels. Don't know how much those cost. So I'm going to use H for hot dogs and P for pretzels. And I can build an equation based on both situations. So the first situation, we had 4 hot dogs. And why did we choose 4 times H? Well, because I know we had 4. I don't know the price of each hot dog, but once I do, I know I can multiply that out. Plus 2 pretzels should get me a total of $18. And my second situation says 3 hot dogs and 3 pretzels should get me $21. And now I've built my system. So we can solve for each variable. You can start by canceling either H's or P's. I'm going to go with my P's. I need to get them to be the same number, opposite sign. So I'm going to start by listing my 2 table. 2, 4, 6, 8. And then my 3 table. 3, 6, 9. Well, I already found what number they have in common. They can both get to 6. So I need one positive and one negative 6. So let's start with getting the top to be a positive 6. Positive 2 times 3 gets me 6. And my bottom to a negative 6. 3 times negative 2 gets me negative 6. And now we multiply out. We multiply the entire top by 3. So we've got 12H plus 6P equals 54. And negative 6H minus 6P equals negative 42. And we add it like it's one big addition problem. 12 minus 6 is 6H. 6 minus 6 is 0. And 54 minus 12 is, or minus 42 is 12. Divide both sides by 6. We get H equals 2. So each pretzel costs $2. So we can answer that first one. Now in the second one, it says if Teresa sells 7 hot dogs and 2 pretzels, then the total cost of the order is blank. So now we got to figure out, but we've got a problem. We don't know how much each pretzel costs. So we got to figure out our pretzels. Now I know each hot dog is $2, so I can just plug that back in to solve for P. And I'm going to plug it into the second equation. So it says 3H plus 3P equals 21. And instead of H, I'm going to put a 2 here because each hot dog is $2. 3 times 2 is 6 plus 3P equals Y minus 6 on both sides. Oh, that's a 21. Minus 6 on both sides. I get 3P equals 15. Divide by 3. That means each pretzel is going to be $5. So therefore, now I can plug it in to figure out how much my total order is going to cost. So I know 7 hot dogs at $2 each plus 2 pretzels at $5 each should get me a total of 7 times 2 is 14. 2 times 5 is 10. 14 plus 10 gets me a total of $24. So we get 2. All right, number 4. The solution set of a system of inequalities include the following points: 4, 5, 4, 5.5, 6, 6, 6.5, but does not include the following points: -2, -2, -1, -3, -2, 2. Which of the following graphs corresponds to the system of inequalities? Well, the first thing I should remember is that anytime I have a system of inequalities, my solution is my double shaded area, or where my colors meet. In this case, we're looking at our double shaded. So our double shaded is our darker area. So I'm looking for the points that are in that area. So let's start with 4, 5. So I'm going over 4, up 5. Now remember, every point is an x comma y. That means you go left and right, and then up and down. So first point, not in the double shaded area, so it is not a possible answer. Second point, we go over 4, up 5, also not in the double shaded area. Over 4, up 5, well, this one's in the double shaded area, but on a dotted line. Next one is over 4, up 5 in the double shaded area, but on the solid line. Now, just off of this first point, we should be able to tell our answer. Well, if we remember, we have two types of lines for a reason. Our greater than or less than is a dotted line. That means it is not equal to. Our equal to sign has a solid line. So anything on the dotted line is not included in your answer. And this says is a possible solution. That includes these points. If it's on the dotted line, it does not include. It is not included in the solution. So our answer has to be letter D. Now, if you wanted to continue to check, well, you would continue to check every other point. All right, number 5 says, look at the system of linear inequalities shown below. So we've got our system. The way I'm going to try doing this is we are going to graph it, and we're going to see which graph matches. So I'm going to go one by one. I'm going to start with the first line. My first line has a y-intercept of 1 and a slope of -1 over 2. That means my directions would be down 1, right 2. So from there, I'm going to go down 1, right 1, 2. So this one works. Start at -1, down 1, right 2. This one works. Start at -1, down 1, right 2 works. -1, down 1, right 2. So all of them have a y-intercept and a slope that is correct to ours. Now let's look at our line. Because this does not have an equal to sign, this should be a dotted line. And that means I can eliminate two answer choices. We've got B and D. Now I also know this is a less than sign. So I know I should be shaded below the line. Remember, if I'm less, I'm under. So I am below. So let's try shading below both of our lines. Well, if we notice, there is only one that is properly shaded below, and that is our A. Now let's say we wanted to keep going and check our work. Well, I know my next one should start at 2 and should be a solid line. We'll both start at 2 and have a solid line. My slope should be up 1 over 1, so they both also have the correct slope. But when I get to the shading, this is a greater than sign, should be shaded above. We can tell that the only possible answer is A because our double shaded area is our darker area. All right. Number 6. Given the system of inequalities, in which of the following graphs the solution set of this system is correctly represented in purple? Now, we don't have purple, but we do know it's the double shaded areas, which are the darker areas, like this and this. So let's take a look. So in this case, these are set up differently because they are not in slope-intercept form. I want to make sure y is by itself. That way I can graph the y-intercept and the slope. So we're going to have to convert these. All right, let's start by moving over our x. So I'm going to minus 4x on both sides. I'm left with -3y is less than. I cannot combine these two because they're not like terms. So I'm going to leave it as 9 minus 4x. Final step, divide everything by -3. I'm left with y. Now remember, anytime you divide by negative, your denominator is negative, your sign flips. 9 divided by -3 is -3. Two negatives make a positive. Now if I type in 4 divided by 3 into my calculator, I'll get a decimal. So I'm just going to leave it as 4 over 3x. And now we can start graphing. Now be careful, our y-intercept is not 4 over 3. That is your slope. Anything attached to the x is your slope. Our y-intercept in this case is -3. So we're going to go in and check that our y-intercept is -3. Our slope, up 4 over 3. So up 1, 2, 3, 4 over 1, 2, 3. That works. Up 1, 2, 3, 4 over 1, 2, 3. That works. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. All right, they all have a good line. Now we check our shading. This is a greater than sign, so it should be shaded above. Number 1, or letter A, works. Letter B does not work. It is not shaded above, therefore letter C does not work, and letter D works. We'll shade above. Now let's check our next one. It says x plus 3y is greater than or equal to 6. So we follow the same steps. Start by moving x over to the other side. I'm left with 3y is greater than or equal to 6 minus x, and we divide by 3. I get y is greater than 2 minus 1 over 3x. And now we graph. Start at 2. Both of them start at 2. We've got down 1, right 3. Down 1, right 1, 2, 3. Oh, this one does not match this line. So that is not going to be, oh, no, we're looking at the wrong one. So start at 2, down 1, 1, 2, 3. This one doesn't match either. So we can get rid of that. Our answer is A. All right, number 7. Jennifer is at an amusement park where roller coaster rides cost 2 tickets each and all other rides cost 4 tickets each. She has time for less than 14 rides and she can use no more than 30 tickets. She makes a list of 3 options before making a final decision. Complete the following sentences. So we are going to build our system and then we're going to check if each of Jennifer's options work. So the first thing we know about Jennifer, her first dilemma is that she has to have less than 14 rides. So there are 2 types of rides here. We've got our roller coasters, which we're going to use R, and all of our other rides, which we're going to use A for all of our other. So her roller coasters plus all of the other rides should be less than 14. Now, the second thing Jennifer is talking about is she can use no more than 30 tickets. So when I'm talking about my tickets, I know each roller coaster costs 2 tickets and all the other rides cost 4. So our 2 tickets per roller coaster plus our 4 tickets per all of our other rides should be no more than less than our 30 tickets. All right, and now let's check her options. So for her first option, she wanted to ride 10 roller coaster rides and 3 other rides. So our 10 roller coasters plus our 3 other is 13. Well, that is definitely less than 14, so that works. But it has to work for both situations. So I'm going to plug in the 10 for the R and the 3 for the R. Well, she's going to spend 20 tickets in roller coasters and 12 tickets in all the other rides. Well, 10 plus 12 is not less than 30. It is more than 30. So option 1 is not viable. Now let's check option number 2. Option number 2 says that Jennifer wants to use 14 tickets in roller coasters and 4 tickets in rides. Well, if she used 14 tickets, that means, and for roller coasters, and each roller coaster is worth 2 tickets, that means she went on 7 rides. And she used 4 tickets. Each ride is 4. All the other rides are 4, so she rode 1 all other. So our 7 roller coasters plus our 1 is going to get us 8, definitely less than 14, and we're going to plug in our 7 and 1. 2 times 7 is 14, plus 4 is 18. 18 is definitely less than 30. So option 2 is viable. And finally, we have option 3. So for option 3, Jennifer wants to ride 4 roller coaster rides and 9 other rides. So let's see if that's going to work. So we've got 4 roller coasters and 9 rides. Well, just in tickets, 2 times 4 is 14, plus 9 times 4 is 36. Well, that is definitely not going to work. So option 3 is not viable. Number 8. So for number 8, it says in Ms. Jimenez's math class, the number of male students is 3/4 the number of female students. There are 2 more female students than male students. Let X represent the number of male students. X is our male. And Y represents the number of female students. Which 2 equations can be used to form a system that determines the total number of students in Ms. Jimenez's class? So they already set up or separated our two equations. We just have to solve them or build them based on our word problem. So it says the number of male students is. So I know is means equals. So the number of male students should equal 3/4 the female students. And I know that is my option A. Now let's look at the second one. It says there are 2 more females. Then, I know then is a turnaround word, so I should be flipping this. So there are 2 more females than male students. So I know my males are going to go first. There are 2 more of them than our female students. And that should be letter D. In this problem, you want to look for keywords, things like is, then, more. We know this means plus, and so forth. So you want to make sure you see your keywords. And finally, number 9, a teacher is buying t-shirts for her algebra class. Long sleeve t-shirts Y cost $12 each. Short sleeve t-shirts X cost $8 each. The teacher wants to buy at least 30 t-shirts and wants to spend less than $400 in all. Complete the inequalities in the system that represent the constraints in this context. So they already built the problem for you. You just have to finish it off by finding the inequalities that are missing. So let's look at the first one that they built. They did X plus Y. Well, I know X represents short sleeve t-shirts and Y represents long sleeve t-shirts. So here they did the number of short sleeves plus the number of long sleeves should be what then 30? Well, if I look at my problem, it says at least 30. That means the lowest she wants is 30. So my alligator should be eating my equation because we eat the bigger number. She wants at least 30, so she'll be okay with 30. So my first one should be 8 greater than or equal to sign. Now my second one, we're talking about our money. So here we're talking about the number of shirts. In our next one, we're talking about the money. Now in this case, it says $12 per long sleeve plus $8 per short sleeve should be what then 400? Well, it says less than 400. So I know I should have my less than sign. Now it doesn't say at most or 400 or less. It says specifically less than 400. So she does not want to spend $400. She wants to spend less than that. So 400 is not included in your answer. Therefore, you cannot put the equal to on the problem. And that is our Module 6 test review.